Hey everybody, I hope you're all doing well. Today we're going over our third day of notes in chapter 1. It's 1.2b, which is additional properties. So our last video we went over the commutative and distributive properties as well as associative. Those are properties you're very familiar with. Today we're going to talk about some that you may have never heard of before, as well as go over some of the other ones you may not be as familiar with. If you're curious, on Google Classroom, I have given you a link to a Quizlet I made that will make some of this easier for you to review. So the properties of equality and identity, the expressions 4k plus 8k or 12k are called equivalent expressions. Equivalent expressions just means they mean the same. So reflexive, a quantity is equal to itself. So that seems kind of silly. X equals X, 3 equals 3. That we're not really going to use much this year. That'll be used a lot next year when you do geometry, because it makes more sense when we're talking about it in terms of segments and angles. Symmetric. If one quantity equals a second quantity, then the second quantity equals the first. So that again is also kind of silly. It says X equals Y equals X. You can flip it. So again, if I say X equals 2, 2 equals X. Again, we're not going to use that one a whole lot. Where we're going to specify what it is, you do use that one when you take an equation and flip it so that your X is on the left. And with the equations, that's no big deal. Again, just a reminder, if I'm going too fast, you're welcome to pause, rewind. That's the great thing about these videos. Also, if you have questions, please jot them down so you can ask me in class. Transitive. This one's kind of neat. If one quantity equals the second quantity and the second quantity equals the third, then the first quantity equals the third. So if I say X equals Y and Y equals Z, I can kind of take the Y's out, and that means X equals Z. Started to write it too. So this means if I know X equals 3, and I also know that 3 equals Y, I can conclude that X equals Y. We will use this one some this year. Substitution, you've used a lot in the past, but you didn't really give it a name of a property. It's when you can substitute an equal property for its expression. So if I know that X plus Y equals 2, and I know that X equals Y, I can substitute X in. So I can say X plus X equals 2. You do this all the time when you do check. So if I do 3x plus 2 equals 5, and I know that x equals 1, your check is you substitute the 1 for the x. So 3 times 1 plus 2 equals 5, and there's your check. 5 equals 5. Again, we use that one a lot. We don't say the property. All right, back to ones you're more familiar with. Additive identity. You add 0, you get what you started with. A plus 0 equals A. 3 plus 0 equals 3. Additive inverse. If you add its opposite, you get 0. So A plus negative A equals 0. Or 2 plus negative 2 equals 0. What is the additive inverse of 2/3? Negative 2/3. Additive inverse is just changing the sign. Multiplication properties. So multiplication identity is 1. So for any product times 1, you get back what you started with. So A times 1 equals A. Sorry, my equal sign looks like a Z there. So 3 times 1 equals 3. Multiplicative inverse, this is your reciprocal. So it's when you flip it. For every number a over b where they're not 0, you write it as b over a. So that's what it is in symbols. A over b times b over a equals 1. So using my example of 3/5, its multiplicative inverse, I flip it, is 5/3, and that gives me 1. So multiplying by 0, anything times 0 is 0. 8 times 0 equals 0. So 6 times 0 equals 0. So what is the multiplicative inverse of 2/3? Well, our additive inverse was negative 2/3. Our multiplicative inverse is 3/2. That's where we flip it. All right, so evaluate, name each property. So I've done the work for you. So what allowed me to take, so what I did is I did 9 divided by 3 and said it was 3. What property allowed that? Substitution. Next, I said 3 minus 3 equals 0. That is the additive inverse. And yes, while it looks like substitution, we always want to use the most specific form we can. So 24 times 1 is what they did here. That is the multiplicative identity. And then they said 5 times 0 is 0. That is our 0 property. And then 24 minus 8, that's substitution. And then 16 plus 0 is our additive identity. And that's how we do those problems. So now I want you to pause and give this one a shot. And then I'm going to go over it. So hopefully you've paused and you're watching now to see how you did. 4 times 2 is 8, so that's substitution. Then I did 8 minus 8 and got 0, which is our additive inverse. Then 2 times 3 is substitution. And then 6 plus 0 is 6 is our additive identity. Now, a review of distributive property, which we have gone over yesterday, is where you take anything that's on the outside and you multiply it by everything on the inside. So go ahead and pause and give these examples a try, and then we'll come back. All right, so here we multiply by 5 and we get 5x plus 25. We get 4b minus 16. Here we get negative 2x plus 1. This one's tricky because you're distributing a negative 2 and multiplying it by a negative 1. So negative 2 times a negative 1 is a positive 1. Again, here it's negative 3a plus 3b, because again, it's negative 3 times negative b. This is just written flip-flopped. You're distributing the negative 1. So it's negative 1 minus y, or minus 1y if you like. And then this right here is just like saying it's a negative 1. So it's negative 1 times negative a minus 1, which is really a plus 1. So here's a nifty little review of your properties. Notice there is only a 0 property of multiplication. So tomorrow in class, we'll do these additional practice. Again, please write down any questions you had and bring them with you. Have a great night.